So welcome everybody for the graduate seminar this afternoon, a week before Thanksgiving. And I'm super excited to have our speaker, Judith Estep, here. Dr. Estep is an adjunct faculty member at the Department of Engineering and Technology Management. She holds a Bachelor's of Science in Mechanical Engineering and a Master's of Science in Operations Research, and also a PhD in Engineering and Technology Management. So one of our very own. She teaches a lot of exciting classes, and I've asked her to talk a little bit about what she is doing for ETM at the start of her talk. But her day job and her important job is that she's the Chief Technology Innovation Officer for Bonneville Power Administration. And she and I talked a few weeks ago, and I said, well, what a year 2020 has been in terms of needs for resilience, and how does resilience work in an organization like yours? And she said, funny that you should ask. This is exactly my responsibility. And so I'm really, really happy that she's here today to talk about her experiences. Thank you, Judith.
Hello, everyone. Can you hear me okay?
Yes.
Great. Thank you for the introduction, and I'm really appreciative of the opportunity to come and speak as part of the graduate seminar series. And so, yes, I am adjunct faculty in the ETM department, and I have taught the technology transfer class in the past, as well as the energy innovations class. This quarter, I'm teaching project management. And that class will also be offered in the springtime. And so I would encourage those of you that haven't taken the class to perhaps sign up in the springtime, or if you are on the call not part of the ETM program and are interested in testing out the program to see if it's a good fit, this might be a good class for you to take. And it's also part of the certificate program where you would take 4 classes and get a certificate rather than having to go through the master's program, or hopefully if you're interested in the PhD program. I would say that the perspective that I like to bring to the classes that I teach is to always have industry practitioners. Because it's one thing to read case studies, talk about journal articles, have projects related to the topic that we're discussing. I think it's really important, and the students that I've had in my class before have agreed to bring in practitioners so that you students have an opportunity to hear how this is really being applied in real life. So I try to bring that to my classes. So I would say if that sounds of interest to you, I would love to meet you and have you attend the class in the springtime. So with that, I will go ahead and get started on the presentation. Again, I appreciate the opportunity to speak here. And like you said, Dr. Yetter, it was very timely that we had this discussion, because that is something that we are very much focusing on at BPA. We have been for as long as I've been there. I know that resiliency is part of our core values, our mission statement, as well as to provide a reliable electric power to the region. But this year has been particularly challenging. And I would say that it's been our preparedness that has allowed us to respond in a way that I would use the term seamless. And I'll talk a little bit about that going forward. So I don't know how many times in the past year, we've heard, oh, the new normal, or it's a changing world, and that the only thing that's predictable in 2020 is unpredictability, right? So one thing, though, that we want to remain constant and available is our supply and delivery of electricity. So to that point, I wanted to share a utilities perspective on how we are further preparing the system to be resilient. The presentation will focus mostly on a sample. I'm going to emphasize it's just a sample of our research activities, and I'll briefly discuss some of BPA's other actions related to system resiliency. So if there aren't any questions about that or any clarity, I'll go ahead and get started on the presentation. So Amir, next slide, please. So this is just an overview of what I'm going to be talking about. So I'll give some background on the Bonneville Power Administration, BPA. I will talk about the office that I manage, the Technology Innovation Office, and then we'll go through, like I said, a sample of some of our research resiliency projects. Next slide, please. So BPA, so there's a graphic of our service territory, and we are a nonprofit federal power marketing administration based in the Pacific Northwest. And then although BPA is part of the U.S. Department of Energy, we are self-funded and we cover our costs by selling products and services. So we market wholesale electric power from 31 federal dams and 1 non-federal nuclear plant. And there are several small non-federal power plants. The dams are operated by the Corps of Engineers and the Bureau of Reclamation. So we don't own the generation. The non-federal nuclear power plant, which is the Columbia Generating Station, is owned and operated by Energy Northwest. And there's a joint operating agency, which is a joint operating agency in the state of Washington. BPA provides about 28% of the electric power used in the Pacific Northwest, and our resources, which are primarily hydroelectric, make BPA power nearly carbon-free. So we also operate and maintain about 3/4 of the high voltage transmission in the service territory. And that service territory includes Idaho, Oregon, Washington, Western Montana, and small pieces of Eastern Montana, California, Nevada, Utah, and Wyoming. Some other aspects of the Bonneville Power Administration is that we promote energy efficiency, renewable resources, and new technologies that are going to improve our ability to deliver on our mission. We also fund regional efforts to protect and rebuild. We have a very robust fish and wildlife program, and this program helps to protect and rebuild the fish and wildlife populations that are affected by the hydropower development. We're committed to public service, and we seek to make decisions in a manner that provide opportunities for input from all of our stakeholders. In our vision statement, we dedicate ourselves to providing high system reliability, low rates consistent with sound business principles, environmental stewardship, and accountability. And I would add resiliency as part of that reliability piece, and I'll explain the difference between those two here shortly. Next slide, please. Going a little bit deeper into the agency, we'll talk about the group that I manage, which is the Technology Innovation Program. So our office now, it serves as a hub of innovation, and it's a centralized focus for all of the research, development, and demonstration activities within the agency. So the program was started back in 2005 from my predecessor, Terry Oliver, and he did a phenomenal job of putting together a program that was actually largely based on a lot of the concepts that are taught as part of the ETM program. Road mapping, portfolio management, project management surely are foundational to our process, as well as tech transfer. So we have evolved our system, our research management framework to really be more streamlined in how we initiate and review projects. We have a continuous review cycle, so really projects can come in at any point into the portfolio. There is absolutely transparency around our project funding, and our goal is to highly leverage our relationships with industry partners, universities, national labs, Department of Energy. And we get our priorities and objectives for our research portfolio from our business line. So we have subject matter experts and executive sponsorship in both power, transmission, and IT. And probably new to the whole framework from when I started was that our executives absolutely require that not only is there benefit of these research projects and a clear understanding of how our research portfolio will contribute to the revenue stream or help to fulfill the mission of reliability and resiliency, but there needs to be an understanding at the very beginning of the research proposal, the research project, of how we're going to put those projects into application. So like I said, it doesn't stop. It doesn't start when the research is finished. We really want to make tech transfer an integral part of the research project. We have a number of different collaborative relationships and resources that we partner with to do research projects, and those are shown. Next slide, please. So for me, this graphic really helps me to understand the difference between reliability and resilience. And I borrowed this slide from the North American Transmission Forum, NATF. We're working with them, and I will talk a little bit about how we're working with them later in the presentation. And so resiliency is about high impact, low frequency events that could have a much larger impact on the system. And so what we're showing for reliability, some of the examples are, yeah, a thunderstorm might take out a line or cause some damage to substation, transformer, you know, some of our other equipment, but it's easily repaired and the impact to the system is temporary. Whereas if you look at things like a cyber attack that disables a large portion of the region or system, or the subduction zone earthquake, or an EMP event, electromagnetic pulse event, those are things that have a much wider spread impact on the system, and that they have significant duration to restore the system. So what we're focused on in this conversation is our resilience effort to really address those high impact events, but things that don't happen as often as some of these other events on the left-hand side. Next slide, please. So now that we have an understanding about how BPA interprets resiliency, I want to present a few of the projects and activities that my group is managing that are contributing to BPA's resiliency efforts. I'll point out again that these projects really are just a sample of what's in our portfolio. More information about the projects that I'm going to be talking about today, as well as really our entire portfolio, can be found at bpa.gov/TI. And there's a resources block on the right-hand side, and you'll find a link to our research portfolio, our current research portfolio. There are project briefs in there that give you background on all of the projects and, again, the benefit and the technology transfer application. Next slide, please. So one focus of our resiliency effort is on system hardening for a seismic event. So I'm just going to leave this slide here for a minute and let it sink in. And I say let it sink in because we're sitting on a time bomb that is going to erupt. It's not if it's going to erupt, it's really when it's going to erupt. And so we absolutely want to be prepared for that, really that subduction zone earthquake, and then any of the other earthquakes that could also cause damage. But our emphasis really has been on that very large anticipated subduction zone earthquake. Next slide, please. We are part of a regional effort, SARA, which is the System Earthquake Risk Assessment. There are another of regional organizations. I believe the Department of Transportation, ODOT, is part of this, as well as other regional infrastructure organizations. And the objective of one of the objectives of the work group is to provide a model that I'm showing here that will help us to identify critical areas. And we use this information to inform and prioritize assets or retrofits that would protect against equipment failure. So you can see this analysis was done for a magnitude 9 Cascadia subduction zone earthquake. And it shows, it's an eye chart on the left, but on the right, it talks about where there could be significant failure to the system, highlighted in those red areas. And a lot of our service territory is covered in those red areas. So we want to make sure that we are addressing the assets that could be vulnerable to a subduction zone earthquake. Next slide, please. Over the years, we've worked with industry and universities. In fact, for our seismic hardening activities, we've worked extensively with Portland State University. And we have our own internationally recognized expert, literally, Dr. Leon Kempner and Mike Riley at BPA. We've worked with them to develop technology solutions for horizontal accelerations to minimize horizontal accelerations. And the technology that was developed is a base isolation. And so isolating critical pieces of equipment will minimize the risk of failures of these components. So what we're showing here is a transformer, and this is at our Ross substation up in Vancouver. And it was our first installation of the base isolation system. Transformers have a very long lead time to procure, and there is a significant investment both in time and cost to replace them. So these are critical assets to the electric grid. So we want to make sure that these are well protected. We've also done research to address the vertical acceleration. And the other aspect of this seismic hardening effort is, along with the SARA piece of it, is we have been able to look for areas where we are most vulnerable and do staging of equipment so that we don't have to carry it over perhaps roads or infrastructure that's going to be damaged in the event of a subduction zone earthquake. So these seismic solutions of both vertical and this base isolation system, they've been built into our design plans for new equipment installations. And the SARA model, again, it helps us to identify and prioritize our equipment retrofit. We have technology transfer piece of the base isolation system. Next slide, please. And because our mission is for our customers and the communities that our customers serve, there are a number of regional utilities that have adopted and implemented the base isolation system. So Seattle City Light, they have installed 4 units, and they're planning to install another one. And Centralia City Light, they have 2 units in process of installation. Next slide, please. So there's also future research that we're planning, and in fact, we kicked off a project this year to look at the vulnerability of our assets to landslides. So what we are identifying here is vulnerable areas for landslides in the event of a subduction zone earthquake. So our efforts will be to model those systems, do what-if scenarios, and to help prioritize technology solutions that will help to protect those assets in the event of a landslide. Next slide, please. So now I'm going to switch gears into a more stealthy world of cyber attacks. So why are we going to be interested? I think it's a rhetorical question at this point. We know that there are lots of attacks on our system, and in 2019 there were cyber attacks in Utah, Wyoming, and California on the electric grid. There are attacks all the time, but we want to prevent those attacks from attempts. There are attempts at attacks all the time. We want to prevent those becoming real attacks and impacting the grid. So these are becoming more frequent, and so we want to have technology solutions in place that are going to protect our system from these threats. Next slide, please. So the Office of Cybersecurity, Energy Security, and Emergency Response, which is CSER, leads the Department of Energy's emergency preparedness and coordinated response to disruptions in the energy sector. And this includes both physical and cyber attacks, natural disasters, and man-made events. So we work with them extensively to provide a test bed for testing some of the technologies. Specifically, we've had a lot of involvement with the CEDS program, which is the Cybersecurity for Energy Delivery Systems. It's funded through the Department of Energy's Office of Electricity Delivery and Energy Reliability. And the objective of the CEDS program is to mitigate the risk of energy disruptions from cyber incidents and other emerging threats within the energy environment. And the emphasis is mitigate. We really, we want to minimize and address the potential for attacks being effective on our system. So the CEDS program organizes R&D efforts with other government agencies, with universities, utilities, with BPA being one of them, and manufacturers. And the aim of the office is to enhance the reliability and resiliency of the nation's infrastructure, again, by reducing the risk of energy disruptions due to cyber attacks. Next slide. So here is how BPA has played with the CEDS program in providing a system to validate the technology. So BPA has served as a test bed for CEDS projects. These are typically managed by the national labs and other industry manufacturers. Our system, our live system, provides the ability, excuse me, to do functional and performance testing, to incorporate user experience testing, and provides realistic data to validate the project models. Next slide, please. There's one particular project that I would like to discuss, and this is the Cyber Attack Resilience High Voltage Direct Current Systems project. And I will shamelessly point out that as recently as yesterday, this project won the Public Utilities Fortnightly Top Innovators 2020 Award. So I know that the project team worked extensively on developing this project with the partners that are listed here on the slide. And I really am excited that they were recognized for their efforts. So the objective of this project was securing HVDC, high voltage direct current transmission, by ensuring that received commands do not jeopardize grid stability on our California-Oregon intertie, which is a 900-mile-long line that provides a huge amount of power to California, and it starts at our Celilo substation. This project simulated an attack by someone who gained control of the DC system and developed a mechanism that ignores those commands. So I'll point out that it was just, well, I said as recently as yesterday that we won the award and the Top Innovator Award. So incorrect control on the HVD systems can cause system-wide outages and costly interruptions to the electric delivery system. This project mitigates the incorrect control arising from any malicious cyber intrusion or operator error by implementing fast distributed security frameworks that intelligently incorporates the physical state of the defended system and blocks incorrect HVDC device actions. So the benefits of this project are that it identifies incorrect control systems that can cause system-wide outages and costly interruptions to the electric delivery system. The project assessed challenges arising from advanced cybersecurity measures in systems with stringent real-time requirements. So that 900-mile line down to California was an ideal test bed. Next slide. And did I mention that we won an award for it? Next slide. The next topic is broadly referred to as space weather. And so this is going to cover geomagnetic disturbances, GMDs. It will cover geomagnetic induced current, GICs, GICs, and I'll also talk about electromagnetic pulse, EMPs. So this slide shows the genesis of the higher energy levels of the solar winds. So you first have coronal mass ejections greatly increasing the energy of the solar wind. The sun experiences about 5,000 of these annually with varying intensity, and the ejections of energy are directional, and as the sun is a massive sphere, only a few of these eject energy towards the Earth. The impact of the Earth's magnetosphere depends on the intensity and direction of the coronal mass ejections. Each ejection carries about a mass of 10 to the 13th kilograms, so that's a lot. Solar wind is always present. Charged particles from the upper layer of the sun's atmosphere are being constantly released at varying levels. The events on the surface of the sun impact the intensity and speed of these releases, and the speeds can reach up to 750 kilometers per second. This energy interacts with the Earth's magnetosphere, and at higher energy levels of solar winds could cause disruptions of the magnetosphere. And this could be a problem for our electric grid. Next slide. So these geomagnetic induced currents that come from the solar events are the result of differences in potential of the Earth's crust over large distances. The current will begin to flow in whatever conductive material exists between the points of different potential. At locations where BPA or other utilities have long transmission lines, particularly with grounded transformers on each end of the line, the transmission line becomes an attractive path for these geomagnetic induced currents. And it can wreak havoc on the power grid, especially on our transformers. And remember, I mentioned that those are have long lead times and they're costly to repair and to replace. So any conductive path, including a man-made conductive infrastructure, becomes a path susceptible to these currents. And BPA, we're in an area of a relatively high resistive indigenous rock. Therefore, the transmission conductors are even more attractive to the geomagnetic induced currents. Next slide, please. So fortunately, we really haven't been damaged by any geomagnetic induced currents significantly. So why? Since 1964, when the 500 kV grid started, so that's the high voltage grid, end-use electric power has grown from 650 billion kilowatt hours to 3.7 trillion kilowatt hours. So that's an increase of 465%, with the 500 kV grid carrying 86% of that load. The high voltage grid has grown from about 30,000 to 160,000 circuit miles, so 433% of an increase from 1964. And this suggests that the grid margins are being reduced because base load that the 500 kV transformers deliver is increasing, but the increase in transmission paths are not keeping up. There were 3 magnetic storms between 1964 and 1986 that didn't appear to cause damage, and that was not at a period of time when the grid was as integrated as it is now. However, there was a storm, an intense solar storm on March 13th of '89, and that caused excessive overheating of a series of connections occurred at, in an APS, Arizona Public Service, shell form transformer, and gassing of a number of transformers helped in northeastern US and Canada, and there were several capacitor banks that had failed. So the system has grown significantly and therefore is more vulnerable to these type of induced currents. So there is a heightened awareness to manage these and look for solutions that will help us to mitigate the risk. Next slide, please. The last space weather event is an electromagnetic pulse, or a HEMP, high electromagnetic pulse. And while they can be caused from coronal mass ejections, we're mostly talking about a nuclear detonation when we're thinking about electromagnetic pulse. And it doesn't cause physical damage because it happens significantly above the Earth via the shock wave, but instead there's damage to our electric system by inducing atmospheric currents over this wide-ranging area. So what we're showing here is the effects, the intensity of the wave that goes out when there's a HEMP, a high electromagnetic pulse, which is about 30 miles above the Earth. The highest fields don't radiate from the point directly below the blast. Rather, you can see that they have a very distinctive shape of a smile. And so the highest intensity is in that red area of about 50,000 volts per meter. And so in this case, the nose has smaller fields, so those blue areas above, like in North Dakota and northern southern Dakota. For our system, it would be detrimental if there was a high impact event over British Columbia, because we would be within that high field intensity. So we really want to look at, and we are looking at models and other ways of protecting our critical infrastructure for these types of events. Next slide, please. We're also working with the NATF, the North American Transmission Forum, on a transmission resiliency maturity model. And this was just recently developed and put out beginning of October was when they released it. And we will be participating in an assessment with the NATF. And basically the objective of the maturity model is to help an organization, a utility, understand how mature they are from a resilience perspective. And so we will be going through a series of questionnaires in 9 different areas and assessing where we are from a maturity, and the outcome will be an assessment of where we are from a maturity perspective. The levels of measurement for maturity go from 1 to 3, and it may not be necessary or appropriate to be at a maturity level of 3. And so leading up to our assessment next year, we will be looking at the individual components and questions and coming to an understanding of, as an agency in these 9 different areas where we will be assessed, where do we want to be from an overall maturity perspective. And so the output of the model will be a report that is provided to the organizations participating in assessments. We'll be able to benchmark against other utilities, and there will also be areas of weakness that are identified, and recommendations, ultimately recommendations would be provided on how to increase our maturity in the different areas that are being measured. Next slide, please. So this is an example of the output that we'll receive. So I mentioned that we'll have the assessment report. The graph up in the right shows the 9 areas where we will be assessed, and the levels of maturity from 0 to 3, really 1 to 3 of level of maturity. And then I like the graphic on the right because it shows us for, like, the first one is resilience program management. The next one is risk identification. The third one is situational awareness. And these are just examples, not representative of any utility in particular. But it helps you to see for the questions that are asked in those individual areas, where you stand as an organization and where you need improvement. And so we're hoping to conduct the assessment in the beginning of next calendar year and have the report be used as a guide for ensuring that our resilience capability at BPA is at the best level. Next slide, please. So I mentioned that there was just going to show you very little bit about the research that we're doing to support BPA's resiliency efforts. There's definitely a lot going on in wildfire mitigation, and in fact, the transmission resiliency maturity model will address that topic area as well. Certainly the pandemic response, our incident management team did a great job preparing and implementing BPA's pandemic response. I would say literally overnight, the vast majority of BPA employees and contractors, we switched to a telework status. Our IT systems, operational systems, and planning, it all continued seamlessly and went off without a hitch. And that's due in large part to our ability to plan for these type of events and put into rapid deployment. So we are also participating in several best practices groups to understand how other utilities responded to the pandemic. And it's also an opportunity for us to share BPA's experiences. But I would say that in these benchmarking efforts and really just discussions with other utilities, and especially at BPA, there is a resounding theme of what's the resiliency and protecting the resiliency of our workforce. There definitely is a heightened emphasis on protecting and ensuring the mental and physical well-being of the BPA workforce. And this was done through clear and very consistent communication and enabling additional time to care for families that have been impacted by COVID. And I want to say personally that as an employee, it makes me very proud of the agency's effort, and I feel that my well-being is of significant importance, and that's very reassuring for me. It absolutely is one less thing I have to worry about. So, and similar examples from many utilities around the country. It was great to see that that was the emphasis. Next slide, please. We continue to work with a lot of collaborative partners. EPRI is a big partner of the Electric Power Research Institute. With BPA, I am part of a value of resilience interest group. So it looks at the really the electric grid infrastructure to include the impact on people. It looks to model a lot of their behaviors and understanding if the system is down, how that's going to impact, in some cases, people that are people that have are at high risk of health problems. And so modeling that behavior into a system and seeing, putting a value on that aspect is very different and than just modeling how the assets of our electric grid are impacted. And so it puts kind of a multi-perspective, if you will, holistic approach on understanding the impact and the need for resiliency. We also are working with the North American Transmission Forum, again, NATF, on a Restore database. And so this program, the Restore program, is designed to enhance the resiliency and reliability of the energy grid by identifying sources of equipment and facilitating replacement of that equipment following a disastrous event. So there is not one that has been established. It's preferred if it's regional. So there's not one that has been established for the Pacific Northwest region. But again, we're working with ATF, and they're going to reach out to our regional utility partners to see if there is an interest to develop a database to use in the event of a resiliency event, and being able to share equipment and have visibility of what's available. Again, also working with DOE, of course, and with the national labs to continue our research and contribute to BPA's resiliency efforts. Next slide. So this is my conclusion, and I would say that in all of the cases that I discussed, they absolutely support BPA's mission, and really to that second point of a transmission system that's capable of integrating and transmitting power from federal and non-federal generating units, and making sure that it's done maintaining our electric reliability and stability. Next slide, please. So you can find out more about, and in fact, our annual report was just published. It's available on bpa.gov. And as I mentioned earlier, if you would like to read more about some of the research projects that I discussed here or look at our entire portfolio, please feel free to go to bpa.gov/TI and you can find more information there. So this concludes my presentation. Again, I really appreciate the opportunity to speak to you all, and I'm happy to take any questions.
Thank you so much, Judith. I'm sure there will be plenty of questions. So two options: either raise your virtual hand so that Amir sees that you want to ask a question, or simply put it in the chat. And while people are getting set up for this, Judith, if I may ask a question, so you talked a lot about the importance of reliability versus resilience. And I'm wondering, what are your thoughts? I mean, there's this old saying that organizations always, the future hits organizations always in the temple and never in the forehead. So it is the unknown stuff that causes the unexpected things that cause really, really big disruptions. So what are your thoughts in terms of, can you be, or what drives you, or what makes you resilient in the face of the things you haven't planned for?
Sure. So I would say that if nothing else this year has taught us is that we really need to focus on preparing as best we can for those things that don't happen all of the time. And what we rely on, again, like I mentioned, our incident management team did a phenomenal job of having plans in place based on their experiences and the different perspectives that they've brought in from places they've worked or experiences that they've had. As well, being able to benchmark with other utilities and organizations to understand how they responded, what things they're considering, and integrating that into our incident management planning and just transmission and power planning as well.
Thank you. Any questions? If not, I have plenty more. Another question along the same line. So I'm working on resiliency in the offshore oil and gas industry, and they are very convinced that an important part is cultural. So above and beyond all the things that you've presented, which is analytical and focused on technology and really assessing risks and being prepared for it, is this idea that high reliable, high resilience organizations just have a culture that makes them discover trends earlier, or makes them question things more critically, and it prepares their workforce for resiliency. Any thoughts on how that fits with what you are doing?
Oh, perfect question. Absolutely. So we just added to our agency strategy a culture strategy, basically, is a component for how do we prepare our workforce to be resilient? How do we prepare them to be innovative? And so, yes, I'm participating on one of those work streams of really implementing a culture of strategy and a strategy of culture into our workforce, and developing to ensure that we have that level of competency. It has a lot of executive support to make sure that we are developing the workforce, but anticipate that it's going to take some time, because that's a really hard thing to do, to change people's mindset, and new people come in, people leave, and so it's going to take a while to make that ingrained in our culture, but it absolutely is an effort that is important to our executive team.
Cool. So I'll put a little plug in. We're currently working on a culture training program, an online program exactly along those lines. So maybe we can take that offline, but this sounds interesting.
Sure. I'm responsible for really identifying benchmark opportunities from an innovative culture perspective. So I would love to speak with you, Dr. Yetter.
That's awesome.
So, not seeing other questions in chat yet, I'll jump in as well and say, as an old electrical engineer, 24 years ago, the power industry was considered kind of the boring backwater for electrical engineering. The hip thing was digital logic, and of course we're seeing so much activity and dynamism in the energy industry now. Can you comment about the changing of the workforce and how that's been affected and how that is helping create a different organizational culture? I mean,
Oh, yep, absolutely. So now it really is a cool place to work, cool industry to be in. And I would say that, especially from an R&D perspective, it's even more exciting because you get to be on the forefront of technologies that really could have an impact. From developing that sort of culture, there is an effort through the Water Power Technologies Office, in fact, and I'm on the workforce work stream, and they're asking exactly those questions: is how do we continue to attract top talent to the electric utility industry? And a lot of the solutions that have come up, definitely outreach to universities. One of the things that I had suggested is that there is a sort of a central area for PhD students or master's students to go, where they can find access to researchers, to find access to meaningful projects that they might work on to develop for their master's thesis or for continuing research in the PhD program. So looking at how we can bring in that new talent by outreach to the universities and providing them with meaningful projects is one way that we're attempting to develop that culture.
And on that
data
note,
analytics.
Yeah, and data analytics.
Yeah, I was just wondering if you could speak to what kind of people you're looking for. Clearly not only power engineers, but also power engineers.
Sure. Yep. So people with expertise in data analytics, environmental scientists, are ops research people in our power group and in transmission planning. Absolutely the electrical engineers. There are civil engineers for doing line design and for just design work in general. Certainly there's economists that are needed, necessary in the power marketing group. And so it's really just a plethora of opportunities and types of backgrounds that could be relevant to the electric utility industry.
So from a personnel development, I've been really impressed with, we've had so many people working at BPA that do their masters and other studies and professional development while working full time. Could you speak about your experience doing a PhD while working at a high level at BPA? I mean, that's really impressive, juggling this. So I know it's a little off topic from the talk, but you were so successful in this.
So I thank you. I appreciate that recognition, but I want to say that the faculty at the ETM program very supportive of students that work full-time and understanding and accommodating. So that is a huge factor. Another factor for me was that I had a very meaningful project to work on. I would say that when I started at BPA, the program did not have a framework for that tech transfer piece. And so I asked, if we're doing research, don't we want to put it into application? So really wanting to understand that process, understanding what made it successful, the tech transfer piece, understanding what made it successful, and developing a framework for managing that. And I would say that that was really important and very critical for me to have meaningful work and access to subject matter experts that would help me to further my research and get to my end goal. It wasn't easy, I'm not going to lie, but it was. I am very glad that I finished it, and I feel that it was an excellent investment of my time.
The only question I'm seeing is if you'd be willing to share the slides so that we could.
Absolutely.
Great. And so we will upload those on D2L for people who want to have a look at them. Oh, now I'm seeing a question from Caleb. Do you consider AI, artificial intelligence? Sorry, it just disappeared on me.
That's a good question. Yeah, it's so the utility industry is very risk averse. And so testing new things on our system, it has to be really well proven. I think before we're at a point of a level of confidence where we would want to go out and test it on our system. And AI, while that is important and has a lot of potential to help us with automating things and managing big data and looking at data differently, we're not at the point of really being able to kind of test that on our system just yet. So we don't have any research projects in our portfolio dedicated to AI, but it's on our radar screen and we are continually watching it. Thank you for the question. So Dr. Yetter, Amir actually has the slide deck, and I don't know if I put it on the first slide or not, but if there are any questions afterward, please feel free to email me. And Amir, maybe you can add that if it's not on the first slide, I'd appreciate it.
Sure. Do you want me to add your Hotmail or BPA email?
No, my BPA address, please.
Sounds good.
Great. Thank you so much for doing that. I'm sure there are people who will want to follow up. Thank you. So if there aren't any other questions, then I think we were done 2 minutes early.
Great.
And I'd like to thank everybody for attending. Thank you very much to you, Judith, for an awesome talk. I learned a lot. I hadn't even thought about space weather in the context of electricity systems.
Yeah.
This was super insightful. And I'm glad that you're investing all of those quiet efforts into resilience. I just turn on my light and it just turns on. and
that's exactly what we want. Yep.
Thank you.
We want it to be seamless and transparent. Of course, Dr. Yetter, thank you for inviting me again. Have a nice weekend.
Thank you. Stay all safe and home in given conditions.
Thank you.
Take care.
Thank
you. Bye-bye.
Bye-bye.